All right, here we go, guys. Yes, Vincent, hi. They will not be. Good question. They will not be, no. Test, yes. No. Nope. All right, here we go. 3 new theorems involving parallel lines, and we're going to go back to talking about perpendicular lines. All right, take a look at this first one here. I got A parallel to B, and B is parallel to C, and I'm asking why A is parallel to C. Take a look at that real quick. Most of you, I wouldn't blame you. Right away, you're like, oh, that's not a new theorem. That's substitution. No, no, no. I'm trying to drive this home. Substitution. If the quantities are equal, not supplementary, not complementary, in this case, not parallel. Okay, so this is not a substitution at all. Right? This is a new theorem, which we'll first write in the packet, and then we will write on your index card. All right, here is the theorem that says if two lines parallel to V, anybody want to think they can finish it? Two lines, in this case A and C, are both parallel to what? The same line. Two lines parallel to the same line are what? Don't even say congruent. Are parallel to each other. Okay? Not substitution. Substitution can only be used for equal quantities. Two lines parallel to the same line are parallel to each other. So here's what I'd like you to do right now. On your index card, please. On your index card. On the front, whatever you call the front of your index card, please write those two givens that I gave you. A parallel to B. So make sure you write given. So given A parallel to B and B parallel to C. All right. Then on the back, of your index card, you can write the conclusion we just came up with, which was A parallel to C, and then you write your new theorem in there. Two lines parallel to the same line are parallel to each other. Again, I just like to have the index cards because I know you guys like to, honors anyway, and AB like to memorize some of the stuff. Oh, good. Questions on this theorem? Two lines parallel to the same line, parallel to each other. All right, here's the next theorem. Now I'm going to change parallel to perpendicular. And what do you think that does? Two lines perpendicular to the same line. All right, so let's check out that one on number 2. Instead of me just giving you the theorem, I want to prove it to you first by doing an actual proof. All right, and this is good review for tomorrow too. All right, again, symbol for perpendicular, meaning what do you know about two lines being perpendicular? Throw anything at me right now. 28, throw anything at me. They form angles that equal 90 degrees, right? Two perpendicular lines, they form right angles. All right, so statement 2, I'm saying 1 and 2 are right angles. How do I know that? If angle 2 and 1 are right angles, how do I know that? 13, how do I know that? Not, you look at that, right off the bat already. Okay, how about 29? Okay, perpendicular lines form right angles. And why don't we put a right angle at angle 1 and angle 2? All right, why are 1 and 2 congruent? Let's see if I can catch anybody here. Why are 1 and 2 congruent? Any ideas? 2? Not here. No, that's all right. 8. Why are 1 and 2 congruent? Hi.
All right angles are.
Thank you. Did anybody want to say corresponding? Why can't I say corresponding here? Somebody tell me, going into tomorrow's quiz, why can I not say corresponding? Orion?
I mean, no, because you don't know.
Thank you. There we go. I need the lines to be parallel, right, everybody, for them to be congruent. They're corresponding, but they're not congruent unless the lines are parallel. Nice, everybody, with their hands up. Love it. So I need to say right angles are congruent. Now that they're congruent, why are the lines parallel? Going into tomorrow's quiz. Why are the lines parallel? 7, why are these lines parallel?
Corresponding angles that are congruent imply that they are parallel lines.
There you go. Perfect. That's what I'd like to see for tomorrow. Guys are on fire. Great, we did the proof. What did we just learn? Well, what was I given right here? I was given M and N, 2 lines that were perpendicular to what? To T, the same line. Everyone agree? So I had 2 lines perpendicular to the same line. And what did we just prove about those 2 lines at the end of this proof? Those 2 lines are not perpendicular to each other, but they're parallel. So 2 lines perpendicular to the same line are parallel to each other. All right? And now go ahead, I'll give you a second. Same thing on your index card, write your givens on the front, conclusion theorem on the back. All right. Everyone all set here? This last one's a beast. This last theorem is a beast. Let you guys finish up. Okay, ready to roll. I made a decision here before class started. I'm not going to do the proof with you because there's just so many reasons that we've never talked about, and I don't want to introduce those reasons right now. All right, I'm just going to go and give you the theorem. Okay. There was just too many reasons that we haven't gone over, and I don't want you to get confused going into tomorrow's quiz. So, but I do want to at least keep the givens and the proof up there so I can refer back to them as I give you this theorem. Now, look how this is a little bit different than the last 2. The first theorem I gave you, both givens were parallel lines. Everyone agree? Last one, both lines were what? Perpendicular. Now I got one of each. All right, I got a pair of parallel and I got a pair of perpendicular. And look what they have in common. They have line what in common here? Line N. I swear I just heard somebody say line E, but I'll just totally disregard that. All right. Here's what this last theorem says, and it is a beast. It says a line to one of two parallel lines and before I finish this, I want to go back up to your givens right now. A line perpendicular to one of two parallel lines. Can you name that line? That is perpendicular to one of two parallel lines. Can you name that line I'm referring to right now? T. Everyone see that? Line T is perpendicular to N, which is also part of a parallel line. So right now I'm referring to line T. All right, and you don't have to make a note of this. I'll just, so in our case, line T right now. So a line perpendicular to one of two parallel lines, ready, is also perpendicular to the, what do you think, other parallel line. So let me just go back up because I like looking at the actual letters instead of the full theorem. You had line T that was perpendicular to N. What did I also know? N, it was part of a parallel line. So that must mean that T and M are perpendicular. All right. Line is perpendicular to one of two parallel lines. It's got to be perpendicular to the other line. Okay? And we'll use this in a second. Questions right now about those three, because now we're going to use them in an actual proof. Yes, more proofs. I know you just want them more and more. Let's do it then. Oh, sorry. You've got to fill out your index card. Go ahead. I'll give you time to fill out your index card with your givens, and then on the other side, my apologies. He's now into a proof. Here we go. Number one. Whew. Look at all those givens. I got two pairs of perpendicular lines, one pair of parallel lines, trying to get C parallel to B. All right, and I want to try to use these new theorems. All right, let's take two at a time. Do you want to take the two perpendiculars, or do you want to take a perpendicular and a parallel? Anybody have any preference here? The two perpendiculars, or do we want to take a perpendicular and a parallel? Okay, let's take the two perpendiculars. What do I notice with the two perpendiculars? I have A perpendicular to S, and I have C perpendicular to S. Here we go. Number 8. Notice anything about A and C?
They're both perpendicular to S.
The same line. What's our theorem say about two lines that are perpendicular to the same line?
They would be parallel.
They're parallel to each other. So because A and C are both perpendicular to S, they must be parallel to each other. And if you got to look back at your index cards, that's fine. Two lines. Need some help. 25. Two lines.
Two lines perpendicular to the same line. Parallel.
Is that the first time you got called on this year?
No.
No? I just felt like it was a brand new voice. Has somebody's number not come up at all? At all. At all. 6 weeks in. Number 9. Okay. It knows now. It knows. It hears us. Okay. Everybody good? A parallel to C. All right. From day one, what did I tell you about your givens? We'll use all of them, correct? What's the only one I haven't used yet? A parallel to B, and what did we just write down? A parallel to C. Let's put those two together. And our first theorem I gave you today. 2. 3.
2 lines parallel to the same line are parallel.
And what conclusion you get from that?
C and B are parallel.
C parallel to B. 2 lines parallel to the same line are parallel to each other. You can just stop at are parallel or are parallel to each other. Questions? Okay, what class are we in? Honors. Honors. So I'm going to force you to do this a different way now. Okay. You guys wanted to start with the 2 perpendicular lines. Let's start with a perpendicular and a parallel line now. Okay. So all I'm going to do is just do a dashed line here. And let's do a brand new proof. But now let's start with a perpendicular and a parallel. And I want to choose a perpendicular and a parallel that have the same line involved. So I know I'm going to do A parallel to B. What perpendicular should I use as well? A perpendicular to S, because they have A as the repeating line. So if you look at that last theorem I showed you, which says if you have a line that's perpendicular to a parallel line, read through that real quick right now, because I'm going to ask somebody for a conclusion you could get from these 2 givens right here. A perpendicular to S and A parallel to B. What should I know about S and B now? Calm down. 25? Oh, hold on. I just want to use these 2 right here.
They're parallel? No, they're perpendicular.
Which lines?
A and B.
A and B. Well, they're parallel, so they can't be perpendicular.
Oh,
That's
C.
A and...
No, sorry.
Okay, hold on. Just calm down. Ready? You got these 2 lines right here, right?
Yes.
You hold on. You have S perpendicular to A. And A is also part of a parallel line, so what should you know about S and B now?
S and B?
S and B, yeah.
S and B are perpendicular?
Perpendicular, yes. We okay there? Because again, a line perpendicular to one of 2 parallel lines is perpendicular to the other line, to the other parallel line. Again, that's a wordy one, all right, but it's going to be used. Bless you. Because there's a lot of perpendicular and parallels going on in that one. But does everybody see it? You have line S that's perpendicular to A, that's part of a parallel line. So the other 2, S and B, have to be perpendicular. All right, now use that with the given we haven't used. I got S perpendicular to B, C perpendicular to S. What do you notice about both lines B and C now? What do you notice about lines B and C? Here you go. 1. Lines B and C are both
Perpendicular to S.
the same line. And what's our theorem say? If I have 2 lines perpendicular to the same line, those 2 have to be not perpendicular, but parallel to each other. And I come out with C parallel to B again. Just a little different method. So 2 lines perpendicular to the same line are parallel to each other. Okay? Little different method of getting there. Yes? Nope. Nope. I just want to show you both, especially using the last theorem I gave you guys. Any questions here? I got one more for you, and then you're on your own. One more. Okay, AD perpendicular to CD. All right, those are right angle there. 1's congruent to 2. Prove BC and CD are perpendicular. Ooh. Can I apply any of my theorems right now? No. I don't have 2 sets of perpendicular. I don't have 2 sets of parallel. I don't have one of each. All right. Is there anything I can use in that given, though, to maybe get another pair of perpendicular or parallel lines so I can use one of my theorems? Going into tomorrow's quiz. You have 1 congruent to 2. Hopefully that you can conclude something. If 1 and 2 are congruent, those are special types of angles, everybody. 1 and 2, special types of angles. I've just given you congruent. Anybody? 1, what are the special types of angles here? 13? See, and it plays around with me too, the generator. What did I tell you? I don't make this stuff up. What did I tell you? It knows.
1 and 2 are alternate interior angles, so CB and DA are.
These are alternate interior, everybody. Alternate interior. And by the way, I've started to notice some people just struggling seeing alternate interior. And I didn't bring this up because it's a little bit embarrassing and almost elementary schoolish to show you, if you are struggling, how to find alternate interior angles. You look for the letter Z. And you ask yourself what angles the Z eats up. Okay, if you ever notice any problem we've done with alternate interior, you will see the letter Z being formed, whether it be forwards or backwards Z, and then whatever it eats up are your alternate interior angles. So if you want to take that, go right ahead. Can't believe I just showed you that. But yes, I do have CB parallel to DA. Alternate interior angles congruent imply parallel lines. That will help me out now because take a look. Notice the given we haven't used, the perpendicular lines. So now you have a pair of perpendicular and a pair of parallel. With what line repeating? DA or AD, right? Everybody sees that. I have AD repeating itself in both the parallel statement and the perpendicular statement. Meaning, what should I know about CD and BC here? What's our third and final theorem say? CD and CB should be parallel or perpendicular. Read it through. Read it through. A line perpendicular to 1 or 2 parallel lines is also perpendicular to the other parallel line. Yes, so I know that CD is perpendicular to BC or CB. And that's our third and final theorem I gave you today, which is a line perpendicular of 2 parallel lines is perpendicular to the other line. All right. Okay, plenty of time here. We're looking at about 15 minutes, maybe 13. There was one No, actually, I'm going to keep it. Did we get rid of, let me just, sorry, get rid of, no, we did. Oh, I gave you a hint too. Look at that. Never mind. I'm keeping it. All right, go ahead. If you want to ask me other random questions about tomorrow's quiz, I'll be around.